Hello, this is the second video to multiplying matrices and seeing the examples. So we have this example right here. We need to compare the dimensions to make sure that we can actually multiply these two. So our first one has 2 rows and 4 columns, and our second matrix has 4 columns and 4 rows and 1 column. And so here we see that these two numbers are in fact equal, so we can actually multiply both of them, and we know that the resulting matrix will be a 2 by 1 matrix. Very well, now that we have checked that, we can go ahead and multiply both of them. So since we know that our resulting matrix will have 2 rows and 1 column, we can just already make a very thin matrix, and now we will go ahead and multiply our first row times the only column that we have, so we know that this result will be found right here. So we have -8 times 4, that's -32. 3 times 0 is equal to 0, so we will add that. 4 times 9 is equal to 36, and then 10 times 7 is equal to 70. If we add all of this, we get 74, and so this goes right here. Now, let's move on. There are no more columns to multiply the first row by, so now we will move on to our second row and first column. And so we know that we will find the result of it right here in our second row and only column that we have. So 1 times 4 is equal to 4, plus -2 times 0 is equal to 0, plus 3 times 9 is equal to 27, and 4 times 7 is equal to 28. So if we add this, we get that our result is 59, and we write it right here. And very well, we have successfully multiplied 2 matrices, and we used to get always square matrices because that's the way the examples were made. But here I wanted to show you an example where the resulting matrix is not necessarily a square matrix. If you don't know what a square matrix is, a square matrix is a matrix where the rows, the number of rows and the number of columns are equal. So if we have a matrix m by n, it is a square matrix if m is equal to n. Now we will see another example to multiply matrices. So here we have these 2 matrices and we want to multiply them. So what we always do first is check their dimensions. So our first matrix has 2 rows and 3 columns, and our second matrix has also 2 rows and 3 columns. And oh surprise, we find out that these adjacent numbers are not equal. So what we will say here is that the answer is not defined. And let's see why this happens. So you know that we need to multiply our first row times every column in our second matrix, and then our second row times every column of the second matrix, right? If we try to do this and taking the corresponding numbers and multiplying them, we try to multiply the first number times the first number in the row times the first number in the column, and you say, it's alright, 3 times 9 is just 27. Now we move on to our second element, so 4 times 12 is equal to 48. But now there's nothing to multiply by 5. And so that's why we need the number of elements in the row to be equal to the number of elements in the column, which means that the number of columns, so here the number of columns must be equal to the number of rows right here. So that is why we cannot multiply these two matrices, because we are missing an element right here. We have nothing to multiply by 5.